Hello, Mr. Ryan, are you alright? Yeah? Okay, so today we look at a simple problem. We're given a list of numbers, a list of pair of numbers, dominoes, okay?
It's
So
a
each
pizza
domino,
thing.
yes, it's each
It's like
number,
the leak code question I did.
yes,
Okay.
each number, so we're given an array of a pair of numbers, for example, array, like this is, we are given an
Isn't
array
it a
of,
daily question?
yes, 2, 1, 3, 4, etc. Okay, so we're given an array. Each array, the elements in array are a pair of two numbers, and each number, for simplicity, we just said one digit, bigger or equal than 1, less than 9, less or equal than 9. Okay, so we want to count the number of the equivalent pairs. For example, 1, 2 is equals to 2, 1, or 1, 2 is equals to 1, 2, right? So basically, if the two numbers in a pair is A, B, and then another pair is C, D. So if we call them equivalent, if A equals C and B equals D, or A equals D and B equals C. Okay? So 1, 2 is equivalent to 1, 2 or 2, 1. Okay. So how many pairs in here are equivalent? We only have one pair, right? 1, 2, 2, 1. Okay. Simple question. So tell me what are your thoughts? How do we solve this using computer algorithm?
Well, we first approached with brute force, but then it took forever to.
Brute force.
Yeah, but then when we did the leak code, it took a long time to get the answer.
So yeah, brute force. So basically we can brute force all the pairs, right? We assume there are n pairs, right? N pairs. So to brute force all the pairs and check, it takes O(n) squared, right? How do we brute force? We talked about this a long time ago, for lots of time, right? So we're given an array. How do we brute force? We can brute force the index. Ryan, can you not spin, please? Okay. So how do we brute force? Yeah, for I in range n, and then for j in range I, right? For I
And then
in range n is the number of the,
answer equals 0.
yeah, for j in range I,
If
this is answer equals 0, right? So if the pair is equivalent, so let's say if f, we have a function f, I, j are equivalent, then we answer plus equals 1, right? And return answer. This is the brute force,
that's different
intuitive.
to the one I did.
I know, but f, we define the f function. F, given two index, we check if these two pairs are equivalent. So the problem with this is that these two nested for loop, this is O(n) squared, right? Why we say it's O(n) squared? O(n) squared is the time complexity. We describe how the problem, how the algorithm performs when the problem size increases. To give you a very simple idea, if there are only like 4 pairs, so how many iterations, right? So 4 pairs, n equals 4. So I in range 4, there will be I will be what? 0, 1, 2, 3, right? And then for j in range I, so j, let's say how many times iterate, right? 1, 2, 3 up to n minus 1 times. Okay, so we added up these together. So it will be 1 plus 0 plus 1 plus 2 plus till n minus 1. So what's the sum of these? You know how to do this, right? The, how do we call it? This is the arithmetic sequence. Continuous, right? So the first item plus the last item times how many times of them divided by 2, right? The same thing with adding the number from 1 to 100. You know, like it's 50, 50. So what's the answer? Is 0 plus n minus 1 times how many times of them? N times, right? Divided by 2. So this is n times n minus 1 divided by 2. Okay, so how do we get the O(n) from here? This is n squared minus n divided by 2. Okay? We drop the constant for when we're analyzing the time complexity. We drop the trivial part because n squared, n is so trivial to n squared, so we just keep the most dominant part. Okay, yeah. So if we draw the graph, this is n, this is O n, right? So O(n) squared will be like that. Okay, so this is O(n). Okay, O log n could be something like that, right? And then O squared n would be like that. O1 would be this way, okay? Yeah. Can we perform better, right? This is too slow. The most important part of this is that this is taking forever, taking time to do that, okay? But let's put this simple, okay? Let's consider this simple example. Okay. Let's say, if I tell you, right? If I tell you the 1, 2 pair has appeared 3 times before. Okay, so let's say, look at this. I'm just telling you, 1, 2 has appeared 3 times. How many more? Answer me this question. How many more pairs if I tell you we have another 1, 2 here? How many more pairs? So I already tell you that we have seen 1, 2, 3 times. I have another 1, 2 pair. So how many more pairs? 1, 2. I already tell you we have 1, 2, 3 times here. Okay. And then now I have another 1, 2 here. How many more pairs? How many more pairs?
3.
3 pairs, yes, because this one, yeah, okay. So if we perform a linear scan from left to right and then remember these same pairs in the hash map or counter, right? And then we can increment the counter, right? Does it make sense? Yeah. Okay. Let's say we have 4 pairs. We have 1, 2, 4 times. So how many pairs? How many pairs can you count from this? You know, how many pairs? 1, 2, 3, 4. How many pairs? How many pairs?
6.
This. Yes. How do you get a 6? Oh, that's quick. How do you get a 6? Why is this 6? Yeah, this is a mathematical challenge question in your JMC, right? Could be in your JMC.
I think
How do you get a 6?
I can just count them quickly.
Yeah. Okay. Then. Okay.
But I feel
Another
like,
more.
I feel like
Another more.
I feel like if you like subtract 1 and
Yeah.
then like 1 plus 2 plus 3. For the 4, you subtract 1 and you get 1 plus 2 plus 3. And then for the 1 over there is 1 plus 2. So for 5, I feel like it'll be 10. And that's 1 plus 2 plus
Yeah.
3 plus
Okay.
5.
Okay. Yeah. Yeah. You can think about it. Let's say I have 100 in there, so you can't do this counting, right? But I can tell you a trick. Okay. This is very important. Okay. Your takeaway. If there are 100 here.
49, 50.
No, 100 numbers. 100. How many pairs would you form out of these 100?
200,000.
Okay, so answer me this one. This is not
No,
about a
because-
single number. This is about how do we.
If there's 100,
Yeah.
you subtract 1 and you get 99. And then because 1 plus 2 plus 3 till 100 is 50-50, you just need to subtract 100. It's 49-50.
Okay. What's the question equivalent? I have 100 numbers. How many pairs? Is this the same thing? I have 100 apples. How many ways to pick 2 apples? Is it the same? Yeah? How many? There are 100 apples. I want to pick 2 apples. So this answer is C. 100, 2 apples. We talk about combination. 100 apples. I want to pick 2 apples. N apple. I want to pick 2 apples. What's the answer? What is equals to n times n minus 1 divided by 2. Okay, you can remember this. You can memorize this. Okay, we talk about permutation or combination. Why? Okay, let's verify. Right, you say 5, right? 5 apple picking 2 apples equals 5 times 4 divided by 2. 10. 4 apples picking 2 apples. 4 apple picking 2 apples. 4 times 3 divided by 2. 6. 100 apples picking 2 apples equals 100 times 99 divided by 2 is equals to 50 times 99. Is it 4? What was your answer again?
The answer was 49.50.
Okay, you might be right. Okay, you might be right. Okay, sorry, my bad. Okay, is it what's this answer?
If
Is
it's actually 49.50.
This is 49.50. Is 5,000 minus the 50. 49.50. Oh my God, you're right. Okay, okay, I'm gonna do this. Okay. Good job. Okay, but this is the formula. Okay, n times n minus 1 divided. We'll talk about this. P P and C, right? Long time ago, right? Permutations, combination, picking apples without the order does not matter. Okay. So look, if we perform this, we count each one, and then we can group it later, right? This is also another way. So do you get my point? Okay. So coming back to this question, right? The tricky part is that how do we make these and these belongs to the same? How do we let's say 1, 2, and 2, 1. How do we make them belong to the same group? I mean, if this number, is 1 digit, how do we know? How do we have a computer algorithm to say, okay, 1, 2, and 2, 1 is actually the same, belongs to the same group? It's not less difficult. How do we do it? Any idea?
Just sort it.
Yes, sort it. Well done. Yeah, we can sort it, right? Sort it works for any numbers, right? We can sort it, right? 1, 2, 1, we sort it. Or we can put because it's 1 digit, right? If this number, we can put the bigger number at the 10th, and then smaller number at the 1, right? And then it also works, right? So 1, 2 will be turning into 21. 2, 1 will be turning into 21, right? If it is only 1 digit, okay? So once we have that, we have the identity for each group, each pair. Then we can put it in the counter, count how many times, and then we can use this formula, right? We can use this formula, sum, right? Let's say we have a counter C the group, right? Ci plus equal 1 for each one, right? So I'm going to quickly write. Okay, I'm going to read, okay? Answer equals 0. And we have a counter, C equals counter. For I in array, okay, for I in array, then we do this identity function, right? We do this C, okay, C, so I'm going to put this number, Fi, okay, let's say CF. F returns the identity of that, right? Turning 1, 2, or 2, 1. Either you sort it or turning into 21, because we want to group the different pairs, 1, 2, and 2, 1 into the same, okay? Plus equal 1. Before that, we can do this answer plus equals C this, right? And then that's it. Or if you prefer, we can just do this update, and then at the end, as I said, we go through this, let's say we already update the values in C. So how do we get a number? We just return sum the values, right? The value will be n times n minus 1 divided by 2 for n in C dot values, right? Okay? Because remember, this is counter thing. If like say 21 appears 3 times, like 45 appears 5 times, okay, this is the counter, C will be equal like that. So what's more important is the values, right? So 21 appears 3 times, 45 appears 5 times. So how many pairs? So 3, for 21 3 times, right? 21, 21, 21, how many pairs? C32 equals 3 pairs, right? Okay, C52, 45 appears 5 times. So how many pairs? 10 times, 10 pairs, right? So how many pairs in total? 10 plus 6, right? Did you get my point?
Mm-hmm.
So the time complexity, we just iterate from left to the right. The time complexity is O(n), but with the help, we need a hash map to remember the pair, the appearance of each pair. So does it make sense? Yeah. Okay. So most important takeaway today, this C function, right? We want to count how many apples, picking 2 apples. Okay. How many apples? Picking 3 apples. Do you know how the equation?
Is it the same thing, just divide by 3?
No. Okay. So this is the equation.
Is it like n minus
C
n times n
n 3. This is equals to n times n minus 1 times n minus 2, and then here will be 3 times 2 times 1. Okay. So you know the pattern, right? You know the pattern. So actually, CNN equals n factorial. Divided by m factorial divided by n minus n factorial. Okay,
so if n equals 10, then there's 10 times 9 times 8. So 9 times 8 is 6. So it's 720 divided by 6.
I might be
So
wrong.
it's
Okay,
not
let's verify
120
this.
divided by
Yeah,
6, which is
Okay.
120. So if you're picking 3 apples from 10,
No, you can't pick 10 apples out of 3.
no, I mean 3 apples out of 10.
Okay, so
700. No, so it is 120 then.
I don't know. Let's verify this. Okay, n equals 3. Okay, C3 Cn3. Okay, Cn3 equals what? Cn3 equals the n factorial divided by, look, this is m equals 3, right? So it's 3 factorial is this one, but this is n minus m factorial, so it's n minus 3 factorial, right? Yeah, look. So these got cancelled out, then we have this remaining. So yes, this is the correct formula, okay? Okay. Does it make sense? I mean, this is particularly very useful to you, because lots of your mathematics challenging question in JMC combination, this combination. Permutation is with sequence, right? When you pick 3 apples, actually when you pick 2 apples, let's say this, C32. 1, 2, 3, you want to pick 2 numbers. How many ways?
3.
3 ways, right? Is it the same as picking 1 apple, right?
Yeah.
Okay, because every time you pick 2 apples, you leave 1 apple, right? So how many ways is 3? 1, 2, 1, 3, 2, 3, right? Okay. So based on this one, if we do a n permutation, if we perform a permutation with this, so we got another 1, 2, and then another pair will be 2, 1. 1, 3 will be another 3, 1. 2, 3 will be 3, 2. Okay. So that's 6 ways. That's the permutation. Okay. Let's call P32. P32. So basically Pnn is like picking. We have n apples. We pick m apples. But with this m apple, we need to do the full permutation of m apples with sequence. 1, 2 is different than 2, 1. Okay. This is equals to Cnn times m factorial, right? So Pnn. N apples, I want to pick m apples with sequence. First of all, let's pick the m apples. Once we have m apples, let's permutate the m apples. Right? Once we have picked 2 apples, we do the full permutation, right? N apples, how many ways to arrange them? 3 apples, how many sequence? 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2. 3, 2, 1, right? We got that 6 is Pnn is equals to n factorial, right? N apples, how many ways to arrange them? How do we get that? I have n apples. How many ways to put the first to choose the first apple? How many ways?
2.
If there are n apples, how many ways to pick the first apples? N apples, right? Does it make sense? Do you get it? Yeah.
I know that.
Yeah. I have n apples here. 1, 2, 3, or 4 apples. I want to perform a sequence. How many apples? I want to choose the first apple. How many ways? 4 apples. 4 ways, right? I can choose 1, 2, 3, 4. 4 apples. Once I choose the first apple, how many ways to pick the second apple?
3.
Yeah, because I already taken 1, so 3 times 3. Once I choose 2 apples, how many ways to pick the third apple? 2, right? And if I choose an n minus apples, then I only have 1, right? So, if we have n apples, I want to permutate the sequence. I have n times n minus 1 times n minus 2 here 1. So this is n factorial. Okay, this is also Pnn. Okay, got it? Okay, that's it for today. Bye bye.
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 See ya.